Welcome to Study Loop.
We're asked in this problem to show that, prove that the force is conservative if and only if the following relations are true. So those relations basically involve the cross derivatives of the vector field F. In fact, what they really are saying is that the curl of that vector field is 0. So it's easy to show that if the field is conservative, then those have to be true. And we just have to write the definition that the field is conservative, that there's a potential whose gradient is then the vector field F. And then, we can just basically take dy dy of this, and we get this, and d dx of this, and we get this, and noting that the order of differentiation doesn't matter if this is sufficiently smooth, and some other caveats, we can see that then, in fact, this equals this. And we can do the same thing by taking the derivative of this with respect to z, and the derivative of this with respect to y, and then the derivative of this with respect to x, and the derivative of this with respect to z, and get these relationships. So it's really that the curl of f equals 0. And it's actually, we can show that the curl of the gradient of any potential is 0. And to go the other way, though, is kind of hard. To say that we know this information and then go back to say that there must be a potential is kind of a much more difficult problem that I don't know if you would have the mathematics to actually prove. You need Stokes' theorem, and basically, again, it's a matter of trying to show that if you have a curl of a vector field is 0, then there must be a gradient. That vector field must be the gradient of some potential. And again, that requires quite a bit of vector calculus, and it's not probably worth going through here. But suffice it to say, if this is true, then there will be a potential function that you could be able to find. It doesn't guarantee that you can find it, but it exists.